All right, number one. Let's look at the homework here. Suppose the newspaper states the probability of rain today is 85%. What's the complement of rain today? So think of what the complement of rain today would be. What's the opposite of raining today? Not raining today. So no rain today. So what's the probability of the complement? Now they want you to do it as a decimal. So the probability of the complement, I've got 85%, which as a decimal is 0.85. So 85%, 0.85. The complement of that would just be 1 minus 0.85. Okay, charge my battery. 85. So it'd be 0.15. So you want to do it as a decimal because they asked for a decimal, which is the same as 15%. You could subtract it from 100% and convert it then if you want. Okay. So let's talk about the probability event is certain to occur. So what's the probability event A is certain to occur? So let's look at our notes. What's the probability that an event is certain to occur? Let's look right here. Probability event is certain to occur, you would say that's 1. 1 means 100%. What's the probability that an event's impossible? 0 means there you go. So it's certain not to occur. So that's P of A equals 0. So then certain to occur 1, not to, certain to occur 0. What is the law of large numbers? So law of large numbers, we talked about that on the top of the next page. In the long run, as the sample increases, the relative frequency of the outcomes get closer and closer to the theoretical probability value. So the sample size increases, the relative frequency gets closer to the theoretical probability. So you see how that's just basically the definition. So as you increase the sample size, if I flip the coin more times, it's going to get closer and closer to 50% heads. If you're using a relative frequency to estimate the probability of an event, would it be better to use 100 trials or 500 trials? So what would it be better to do if you want to use the law of large numbers? Would it be better to use more trials or less trials? It would be better to use more trials, right? So use 500 because the law of large numbers. So the more trials you have, the more likely you're going to get an idea of what the real outcome should be. So like the more times I flip a coin, the more likely it's going to be a 50-50 breakdown. Okay. All right. Number 4, recent survey of 1,010 U.S. adults selected at random showed that 625 considered the occupation of firefighter to have a very great prestige. Estimate the probability of the U.S. adult selected at random thinks occupation of a firefighter has great prestige. So what I could do is think back to the notes here. Pretty simple. I've got the number of favorable outcomes over the total. So remember what I did here was I took the amount that considered it was a great prestige, 625, and I divide it by the total. Okay, just kind of like I did here. The amount in that group that wear glasses over the total. Okay, and then I want you to divide that, and then we've got to do the probability to the nearest hundredth. So I got to round this to 2 spots, 0.62. Okay. Okay. On a single toss of a fair coin, the probability of heads is 0.5. The probability of tails is 0.5. If you toss a coin twice and get heads on the first toss, are you guaranteed to get tails on the second toss? So let's think about this. So if I flip a coin and get heads on the first one, am I guaranteed to get tails on the second one? No. Okay, so is it each outcome is equal likely regardless of the previous outcome, or no tails will never occur on the second toss? Equal likely, exactly. So if I get heads on the first one, that has no impact. They call those being independent events. If I get heads on the first one, if it's a fair coin, it shouldn't impact the probability of getting heads on the second one. So that will, it will. I could get 5 heads in a row. Okay, but that sixth one, it could be heads or tails, equally likely. All right. Consider the following. So what is wrong? Basically, we're going to say, are these correct? Explain why negative 0.41 cannot be the probability of some event. So what did we learn about the probability of a certain event? It has to be what? It has to be between 0 and 1. So you can't have negative probabilities. So we talked about that here. Probability of an event must be between 0 and 1. So we can't have negative probabilities. Explain why 1.21 cannot be a probability event. It must be between 0 and 1. It must be an integer. It must be negative. It must be between 0 and 1. Okay, it has to be between 0 and 1. Explain why 120% cannot be the probability of event. What's 120% as a number? 1.2. So what do we know about that? Between 0 and 1, exactly. Can the number 0.56 be the probability of the event? No, this is too large. No, it's probability can't be positive. Yes, it's between 0 and 1, or yes, between 0.5 and 1. Yes, and it's between 0 and 1. Good job. So that will probably be showing up on your test, so you'll do good on that. Okay, 7. Let's look at that here. Going right along. Isabel Briggs Myers is a pioneer of the study of the personality types. Personality types are broadly defined according to 4 main preferences. Do married couples choose similar or different personality types in their mate? The following give an indication. So there's 4 indicators on the Myers-Briggs test. You have all 4. There's 375 married couples. Okay. Use your data to estimate the probability they'll have 0, 1, 2, and 3 personality preferences in common. Enter to 2 decimal places. So I've got 375 in the total. How do I find the probability of 0 being in common? Yeah, I take the number in that outcome, the number in that group, divided by the total. So the number in that group divided by the total, and I convert it to 2 decimal places, so 0.08. Okay, for 1, I take the number in that group, I have 69, divided by the total. So 0.184, so 0.18. 2, I take the number in that group, 119, divided by the total, 375. 0.32. 3, I take the number in that group, divided by 375. 0.33. 4, I take the number in that group, 35, divided by 375. 0.09. So that's the number in each group divided by the total. Do these probabilities add up to 1? So a little bit of a tricky here. Should they add up to 1? Now, they might not exactly add up to 1, but should they add up to 1? Yes. And yes, because why? They cover the entire sample space. What does that mean? That means these outcomes cover all the possibilities you could have from this table. 0, 1, 2, 3, 4. It covers all the possibilities, so these should add up to 1. What is the sample space of this problem? So what is the sample space? Yeah, 0, 1, 2, 3, 4 personality preferences in common. It's 0, 1, 2, 3, 4 personality. So it's all the possibilities. So it could be 0, could be none, could be 1, could be 2, could be 3, or could be 4. Okay, so all right. Let's look at 8. So you roll a single die and count the number of dots on top. What sample space of all the possible outcomes? Are they equally likely? So you roll a die, and I guess we'll assume it's a fair die, and you count all the outcomes on top. So you know a die has a die that has a fair die like 1, 2. Oops, 2's on the other side. 2, 3, 4, 5, and 6. So you got a die there. So 1, 2, 3, 4, 5, and 6. Now, if I were to roll this die, what's this sample space? 1, 2, 3, 4, 5, 6. What do we know about the outcomes? Are they equally likely or not? Equally likely. So assign probabilities for the sample space. So enter as fraction. So what's the probability I get a 1? 1 out of 6. So I got one possibility, one favorable one out of the total 6. What's the probability of getting a 2? So 2, just 1 out of 6. It's probably getting a 3. So you see how it's just each of the outcomes are equally likely, so their probabilities are going to be the same. 3 out of 6, 4 out of 6, 5 out of 6, and 1 out of 6, 5, and then 6. So 1, 2, 3, 4, 5, 6. Each of them is 1 out of 6. Do the probabilities add up to 1? So 1, 6 plus 1, 6 is 2, 6, plus 1, 6 is 3, 6, plus 1, 6 is 4, 6, plus 1, 6 is 5, 6, plus 1, 6 is 6, 6. So it's 1. So they do add up to 1, and the reason why is because they cover the sample space. What does that mean? They cover all the possible outcomes. What's the probability of getting a number less than 3 on a single throw? So what's the probability of getting less than 3? Less than 3, it would either be a 2 or a 1. So it'd be 1, 6 plus 1, 6, which is 2, 6. So it'd be 1/3. I think you might be able to get 2, 6 there. What's probably getting a 3 or a 4? So a 3 or a 4 means I add 3 plus 4, 1 6 plus 1 6 is 2 6, which is 1/3. Said you might be able to leave it as 2 6 on there. I'm not for sure. I could let me try it just for fun here. I would 1/3's better. I was going to see if they'll accept 2 6. Okay. All right. They accept it.